So a major concept I want you to remember as we're going through logarithms and exponentials is they are actually inverses of each other. So the logarithm is the inverse of an exponential, which makes sense because if you remember how we solved exponentials, or solve for inverses, you always try to solve for your x. The only way you can do that is through a log. There's no other way to get rid of that 3 onto the other side. So we're going to talk about how to graph them. Next time we'll start learning how to solve, but right now we're going to learn how to graph. So I just want to show you, just as a reminder, inverses are just switching the input and output. So meaning the y's and the x's are getting switched. So all these coordinates are just getting swapped is what's happening. So 1, 0, 3, 1, 9, 2. So if I plot all those, so we've got 1/9 negative 2, 1/3 negative 1, 1, 0, 3, 1, and 9, 2 will be way out there. You'll get something that looks like this. So for exponentials, instead of having a horizontal asymptote at y equals 0, you're actually going to have a vertical asymptote at x equals 0, so right here. And this also makes sense because this is supposed to be a reflection over the line y equals x. And so that looks like a reflection. So when it comes to logarithms, since they're inverses, that means the key points just reverse. So we have 1 over b negative 1 instead. We have 1, 0 instead of 0, 1. And you've got the base 1. So this is 1, 0. This is negative 1. This is 1. So it looks something like this when you draw a logarithm. And the asymptote would be at x equals 0. So when it comes to logarithms, same idea applies as before. Same types of parent function rules. It just will look like this. So the k will tell you how far up or down you're going. H will tell you how far left or right, and you always go opposite. A tells you your y distortions or your vertical stretch or compressions. C tells you your x distortions or horizontal stretch or compressions. So let's see a few. So this one, we've got 2 log base 5 of x plus 1. So since the plus 1's outside, that tells us we're shifting our graph up 1. And remember, we have a vertical asymptote now. So I'm just going to draw a vertical asymptote going like this. And if you're a key point person, since your base is 5, you would do 1/5 negative 1. You would do 1, 0, and 5, 1. Okay, so those 5s are just right there at that part. And then, if you're a key point person, this 2 in front would affect your y values, so you'd multiply all your y values by 2. And then you'd go ahead and from this cross, you would go ahead and graph it. If you're a table person, one tricky part about table is you just need to make sure you know exactly where that asymptote is. Otherwise, you'll get a domain error. You're just going to plug things either to the right or left, whatever's going to make the argument positive. So in this case of 1 would give me a positive argument. So I could do like 1, 2, and 3. And you could plug those in. Just know that if you're going to do table method, you do have to do change of base formula, because there's no other way to plug this in without the change of base formula. So feel free to do that. I'm not going to go ahead and find those values. I can show you maybe I'll explain some better numbers that might help so you can do it in your head rather than doing table or using a calculator. But let me go ahead and do key points really quick. So I get 1/5 down 1, so that's right here. I get, or down 2, sorry, because we multiplied by 2. There we go, fix that. We still get 1, 0. I go back to the cross and I have 5 over 5 up 2, since we multiplied by 2. And I go ahead and draw my shape. Now, like I said, for those who are doing table method, I usually pick easy ones. For instance, anything that makes the argument 1. So 1 would make the argument 1 in this case. So 2 log base 5 of 1 plus 1. The reason I choose 1 is because I know log base, regardless of the base, if I have a 1 right there, it's going to always be 0. So this is just 2 times 0 plus 1, which is 1. The next thing I do is I match the base. So I figure out what x value is going to match that base. In this case, it's just x inside. So I'll do 5. 2 times log base 5 of 5 plus 1. Well, log base 5 of 5 is really easy as well, because anytime the base matches the argument, your answer is always 1. So this would be 2 times 1 plus 1, which is 3. So I have the coordinate 5, 3. If you want another one, what I often do is I figure out what makes it a fraction, or I'll just do a really big one, like 25. I know 5 squared is 25. And then I can do log base 5 of 25 plus 1. And that would give you 2 times 2 plus 1, which is 5. So pick what you want, whichever method you want to do, but that's kind of how I sometimes do table method. Let's go ahead and do another one using both methods. So let's do this one. Remember, sometimes they'll throw things out in the front that are actually horizontal shifts. Or not horizontal, sorry, vertical shifts. So this is actually going up 3 and left 2. You don't have to move it at the end, but it might help to see it at the end. So right here. These are logs, so they have vertical asymptotes. And if I were using key points, the key points I would use would be 1/2 -1, because remember this base tells us this number. I'd have 1, 0, and then I'd have 2, 1, because of that. And the only thing that's happening is this negative in front. So that tells me I'm going to multiply it's outside, so it affects my y's. So I'll multiply my y values by -1. And so if I were doing key points, I'd go from the cross over 1/2 up 1. From the cross again, I'd just go over 1. And back at the cross, I'd go right 2 down 1. So it would look like this. For those people who really like to use the table, just as a heads up, one thing that you can do is, like I said, pick numbers that match or that give you 1. So I'd try to find an x value that would give me 1 in the argument. So -1 would, because -1 plus 2 is 1. So 3 minus log base 2 of 1. That's nice because when you plug in, or when you do a log base anything of 1, it's always 0. So this is just 3 minus 0, which is 3. So I'd have -1, 3, which is this coordinate. And then I always make sure I plug something in that's going to give me something that matches the base. So the base is 2. So 0 plus 2 would give me 2. So this would be 3 minus log base 2 of 2. And that's easy because the base matches the argument. So that's always 1. So that'd give me 2. So those 2 points would actually be plenty. I would know pretty well what the graph would look like.